Do we remember anything else about our sines, cosines, and tangents? Besides that they're a thing. So they're also buttons on our calculator, yeah? Okay. Do we remember what a trig function does? No, maybe? No? Okay. So in general, a trig function relates the side lengths of a right triangle to its angles. So in other words, remember that we had this idea of what like pi was. Pi allowed us to kind of have a ratio between a diameter or radius to its circumference, and so that's how we get the measurement of pi. We have a similar idea with our triangles, so remember that our angles are angles of rotation, so they're also angles that are kind of going to be moving in a circular motion. So we're talking about these angles of rotation, and we want some way to be able to evaluate, okay, these angles of rotations as like straight lengths, so the sides of your triangles, which are straight lengths. And so our trig functions are what allow us to do that by relating our sides back to that angle. And so the other property or theorem that we want to remember is our Pythagorean theorem. Do you remember what that one does? Do you remember what it is? It is a squared plus b squared equals c squared. I tend to leave it as a squared plus b squared equals h squared, because h stands for hypotenuse. Because some people sometimes forget that the c is the hypotenuse, and we'll just put in one of the side lengths there. So basically our Pythagorean theorem relates the three side lengths to one another. It allows us to solve for a side length given a right triangle. So all of this that we are talking about right now, our trig functions, our Pythagorean theorem, our unit circle, is all only helpful for right triangles. Later on, we will look at some things with non-right triangles, but we are not there yet. So do we remember what the relationship for sine is? Did any of us learn the fun acronym? So yes, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And again, these are referring back to the side lengths of a triangle. And then tangent is
opposite over adjacent.
Agreed. You do need to have those memorized if you do not already, but most of us should have seen those in our geometry classes. Now, there's actually 6 trig functions. In lower grades, we tend to focus on the first 3, which is sine, cosine, and tangent, but we do have 3 more. And those are what we call our reciprocal functions. What does it mean to be a reciprocal? Opposite, specifically the opposite of a fraction, yes? So I'm going to be flipping a fraction. So we call these cosecant, secant, and cotangent. And those are the reciprocals, or in other words, 1 divided by sine, cosine, and tangent.
I thought it was -1.
You thought what was -1?
that like on the calculator it says.
That is an inverse trig function.
Oh, okay.
So like inverse trig functions, which we will talk about later on this semester, allow us to go backwards. So instead of equaling two side lengths, it will equal the angle length. So that's the inverse of a trig function. These are the reciprocal of a trig function. Which brings about a good point. We actually don't have buttons on our calculator that calculate these. So the only way to do it is to plug it in as a fraction. So you would just type in, like if I wanted to find secant of whatever, 60 degrees, I would just type in 1 divided by cosine of 60 degrees into my calculator. And that's the only way that we have to calculate them. The other thing to be careful about, usually most people are okay with the cotangent and tangent, but do notice that our cosecant and sine and our secant and cosine, people really want the C's and S's to match up, but they don't. So they're the opposite. So just be careful with which ones you're pairing with each other. But the nice thing is that because we know what sine and cosine are, and tangent, we can just flip each of these fractions, and that's what's going to be cosecant, secant, and cotangent. So we would have hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. Yeah.
Is the slashes for like cosecant and sine? Does a slash mean it's like a fraction?
Yeah, it's just like 1 divided by.
Okay.
It just, the formatting doesn't look
Yeah.
great on here, but yes, it's just 1 divided by sine.
Okay.
1 divided by cosine.
Okay.
Other questions? Some people still writing, so I'll wait a second. So let's look at an example. Find the trig functions for a triangle with opposite leg length 7 and adjacent leg length 4. So, with a lot of these, to me it's helpful to go ahead and draw a picture. Does it matter where I draw my theta? Okay, remember theta just means angle. Can I draw it on either one of these two? Yep, the only thing that we have to be careful about is then, depending on which one you drew it on, right, I need to make sure that the opposite of that angle is 7 and the adjacent is 4. So if I had drawn it on the top, then those two side lengths would have switched. Okay, so it does not matter how you draw the picture, you just have to draw it accurately based on what the instructions say. So what else do we have to find in order to be able to find our trig functions? Cool, and what can I use to find that?
Pythagorean theorem.
Yeah, which says that I have a squared, which is 7, plus b squared, which is 4, equals our h squared. So 7 squared gives us
49.
plus 4 squared is 16. So what do we get there?
65.
Okay. And then how do I solve for h? Square root it. Is the square root of 65 going to be a nice pretty number? Nope. I also can't even reduce that because the only thing that goes into it is 5 and like 13. So that doesn't help me much either. Now one thing is unless your directions say round to the nearest whatever 2 or 3 decimals, okay? If they don't say that, then we leave our answers exact, meaning that I'm just going to leave it as the square root of 65. Because if I were to plug that in my calculator, you're going to get a not nice, pretty number, and you would have to round it. So if it doesn't say round, then we don't. So that's our hypotenuse. So then, what do we know that sine is?
Opposite of our adjacent, or hypotenuse.
Hypotenuse. So what's our opposite? 7. And we found that our hypotenuse now is square root of 65. Now, we are big kids now, and we can do big kid math, which means that I do not require that you rationalize that. What do we mean by rationalize?
Square root.
Yeah, so to rationalize something means that we're not allowed to have a square root in the denominator, but it's still just a number, and so it doesn't really matter where it is. I'm not quite sure why that notation is more common in lower levels, but in like pre-calc and calculus, we don't care where the square root is. Now, I will say in some of your textbooks, or like if you're checking your answers online, things like that, they might still rationalize it. So, if I wanted to rationalize that, how do I rationalize a fraction? Do we remember? No, okay. We multiply the top and the bottom by whatever the square root of the bottom is. So I multiply the top and the bottom by a square root of 65. So I get 7 square roots of 65 divided by, well then square root of 65 times square root of 65 just gives us 65. But again, these two things are equal, so I have no problem with you leaving it as 7 over the square root of 65. Now, I don't want a decimal approximation, but I'm okay with the square root being on the bottom. Alright, so then for cosine, what's our answer going to be? 4 over. And again, we're going to leave it like that, but if you needed to rationalize it, you can. What's our tangent? So opposite over adjacent. 7 over 4. And then the next thing is once I have those three fractions, my cosecant, secant, and cotangent are just going to be the reciprocals of those. So we're just going to flip it. I have a square root of 65 over 7, a square root of 65 over 4, and then a 4 sevenths. Yes, no biggie. So are we all okay with our trig functions? Yeah. Okay. We will be doing some more stuff with our trig functions a little bit later on, so they're not going away. So we'll get some more practice with them as we move on. Okay. But for right now, remember, our unit circle is this thing that we're going to be putting like all of this information that we need on. So you're going to want out your unit circle handout that I gave you. Because up until now we had all of our angles, okay? But like we just talked about, trig functions come up a lot when we're dealing with triangles and things like that. So we also want to know our sines and cosines for all of those special angles on our unit circle. Yes, no, maybe. Okay. So if you notice, there's little coordinates on the outside, and those are going to be where we're going to put our sines and cosines. Yes? Now, let's put it this way. There are two approaches to the unit circle, okay? One is teachers just give it to you and say, memorize all this stuff, okay? And don't give you any context as to why we get these things, where we get them from, so forth, right? But we've slowly been building ours because, yes, at the end of the day, you do have to memorize parts of it. But I also want you to understand where it comes from, because to me, it's easier to memorize or understand something if you know where all the pieces are coming from. Are we with me there? Okay. So we need to put in those sines and cosines, which we will, but I want to show you where they come from. Now, do you need to be able to do this part in the future? No. So you do not have to write all of this stuff down. I'm just going to show you kind of how we get all of these values. Are we with me there? Alright. So, if we recall back to geometry, we have two special types of triangles. Do you remember what they are?
30, 61.
Yep. And a
45, 45.
yeah. Which, if you notice, 30, 45, and 60 degrees are all the three angles that we have in our first quadrant. Yes? Which is, one, those are your special triangles from geometry for a reason, because they show up a lot. And two, they're on our unit circle, because they show up a lot. So, now we need to, we're trying to figure out what sine and cosine are of these angles. Okay? But we said that sine and cosine relate the angles to the what? Side lengths, yes? So we need information about our side lengths. Are we okay with that? Alright. So these are our right angles. We're going to label this one as 60. This one as 30. Both of these would be 45. So far, so good? Now, here's the fun part. Do we remember the relationships between the sides of our 30, 60, 90 triangle? Yes? Maybe? What are they?
The short side is half the hypotenuse.
Okay. So we're going to label that as x and 2x.
And then the other side is times the square root of 3.
Agreed. If you didn't remember that, then that's what they are. Again, for the purposes of this class, this is about the only time that we will be using this, so you do not need to have that memorized. Now, eventually, we're going to have some values from this that you will have to have memorized. And so it's good to remember, like, oh, these come from our special triangles, which is why when we get to our sines and cosines, we're going to have a lot of 2's and square roots of 3's in it, and that's because it's coming from these formulas. So what type of triangle do we have over there?
45, 45, 90.
Yes, which is also, we talked about it a little bit ago.
Oh, I saw.
Isosceles, right? Because two of my angles are the same. That also means that two of my, yeah, your side lengths have to be the same. So here we have x, 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 square roots of 2. And if you needed to, you could use your Pythagorean theorem. If I know that two of them have to be x, right, I can solve for my hypotenuse, and that's where we get that x square roots of 2 from. Are we all with me there? Yes, no, maybe? Alright. Now, again, our goal at the end of the day is to make our lives easier for ourselves. Yes? So remember that when we were doing our little paper plate project or activity, yes, we said that like our radius was a unit. So we kind of were able to say like that's r, right? And so it was 1 radius unit. So when we found our circumference, instead of saying 2 pi r, we just said it was 2 pi times 1 radius, so we just said it was 2 pi. We're going to do the same thing here. We're going to be building, okay, again, like these different triangles around our circle. Yes, no, maybe. But again, we want to make our lives easier. So we are going to say that our hypotenuse, okay, or in other words, the radius of our circle is going to be 1. Okay with that. Which is why it's called the unit circle, because it's a unit of 1. So that's where we get that name from. So what that means is going to happen, right? So all of my hypotenuse, no matter where I draw, my triangles. As long as we go to the x-axis, okay, my hypotenuse for that right triangle is always going to be 1. You okay with that? Which then allows us to find some information about these. Yes, no, maybe. Because if I know that 2x has to be 1, then what must x be?
1/2.
Which also means that now this side is 1/2. Agreed? And then my third side would technically be 1/2 times the square root of 3, but we just write that as square root of 3 over 2. Yes, no, maybe. So this side length is 1, this side length is 1/2, and my other side length is square root of 3 over 2. Now we want to do something similar for our second one. So we have that this is going to equal 1 again. So what does that mean that x is? So if I divide square root of 2 over, what would I have? 1 divided by the square root of 2? Or, now for purposes of our unit circle, it's just standard notation again. So you're going to see it as square root of 2 over 2. Okay, because again, that's me rationalizing. So multiplying the top and the bottom by square root of 2. Yes, no, maybe. Are we okay with that? And the reason why that is helpful is because now that I have all 3 sides of my triangles, can I find sine and cosine for those? Yeah, right? We just talked about how sine and cosine relate our angles to our side lengths. So now we're able to find sine and cosine of 30 degrees, 45 degrees, and 60 degrees. Yes, no, maybe. Okay? So, since I'm running out of space here, I am going to write those down here. So, what did I make this one like? I think I made this one my 45. This one is also 45. And that's my 90. And we said that this is 1, this is square root of 2 over 2, and this is also square root of 2 over 2. So, remember that sine is what over what?
Opposite.
Yeah, so opposite. So opposite of 45 degrees is our square root of 2 over 2. And then what's our hypotenuse? 1. So we just divide by 1, so we get the same thing. And we can also do the same thing with our cosine. Yes, no, maybe? So that gives it for us for our 45. We can also build that out the same way for our 30, 60, 90. So again, we said this is 1, this is our square root of 3 over 2, and this is our 1/2. So let's start with our 60. So again, sine of 60 is going to be opposite. So square root of 3 over 2 divided by 1. So it's just square root of 3 over 2. My cosine is going to be the adjacent. So that's our 1/2. Yes. And then lastly, our sine and cosine for our 30 degrees. Notice I can get from this same triangle. The only difference is going to be that the sides are flipped from the 30. So we get my opposite for my sine of my 30 is the 1/2. And for the adjacent, it's the square root of 3 over 2. Alright, so that's where we'll stop for today.